So let's recap our some definitions of the vectors in two dimensions and try to solve a different question here. So we said that a vector is a directed line from initial point to a final point. So in this case, our vector is given by uh, x final minus x initial and y final minus y initial. Okay, so this is the overall x value and this is the y value. Okay, so this is kind of an ordered pair, but this is actually the x length of the vector and this is the y length of the vector. Okay, and then we said that uh, a vector space is a set of all vectors in two dimensions such that these two conditions are fulfilled. That scalar multiplication is the multiplication of each component separately, and the addition of each vector, addition of two vectors can be done by correspondingly adding the two x and y components. Okay, and then magnitude of the vector is just the x component squared plus y component squared square root, and if we multiply a vector by a scalar, then the direction does not change. I mean, it can change in the exact opposite direction. And we define this unit vectors in x direction and unit vectors in j direction, and a unit vector of v in the direction of v is just v divided by the magnitude of that vector. Now the question is this: we have p1, p2 up to pn some points in coordinate plane. What is the sum of all these vectors p1 up p1 pi plus 1 from I is equal to 1 to n minus 1? So let's say that our p1, this is equal to x1 y1, p2, this is equal to x2 y2, and note that these are points, these are not vectors, so that's why I'm writing ordered pairs here. So and then pn, this is equal to xn and yn, correct? Okay, now what is p1 p2? This is equal to, now I can say vector x2 minus x1 y2 minus y1. So I should say so y2 y minus y1. Similarly, what is p2 p3? This is equal to x3 minus x2 and y3 minus y2, and so on. So what is this sum? So this sum is p1 p2, this is our first term, second term is this guy, and what is the last term? The last term is p of n minus 1. The last term is p of x minus 1 and p of n. So this is xn minus xn minus 1 yn minus yn minus 1. Okay, now if you move on, if you add this guy to this guy, x2 minus x1 plus x3 minus x2, you will see that x2 will cancel out with this x2, and if you add the next term, x3 will cancel out with the next term, and similarly all the terms will cancel out with the next term which is on the other side of the subtraction sign. So we are all left with just this guy and this guy. So this is equal to xn minus x1 and then yn minus y1. minus y1. Okay, so then this is equal to what? This is p final minus p final minus initial, right? So we have p1 pn. Okay. Now note that here also this last term is what? This is pn minus 1 pn. Now this means, so algebraically we can say that okay, we can add each component and see what terms cancel out. We end up with this term. But geometrically we can say that here we are going from p1 to pn using many different points, p2, p3, p4, p5 up to pn minus 1 and then last one pn. And here we are just going from p1 to pn vectorially, directly, without any stops. So the length and direction, whether we go from p1 to pn this way or that way, is the same. Okay, so algebraically this means that we can cancel out the intermediate terms. Geometrically it means that if we go from p1 to pn directly or we go through stops, we end up with the same immediate vector. Okay, so this is another application of how we can play with the geometric form of the vectors and the algebraic form of the vectors. So this is very important to know. We have to always remember that there is a geometric interpretation and there is an algebraic interpretation. Okay, in some cases one of them is easier to do. Okay, but this is very handy to know that there are at least two types of interpretations possible when we are dealing with vectors. Okay, so this is it for another example of how we can play around with the definition of the vectors and see how we can interpret some results. Okay, so hope it was easy to understand, and thanks for watching. Hope you liked the video.